Elements of Earth's magnetism. The physical quantities which determine the intensity of Earth's total magnetic field completely in magnitude and direction are called magnetic elements. Three elements of Earth's magnetism are angle of declination, angle of dip, and horizontal component of Earth's magnetic field. Angle of declination. The vertical plane passing through the axis of a magnetic needle suspended freely through its center of gravity is called the magnetic meridian. Similarly, the vertical plane passing through the line joining the geographical north and south poles is called the geographical meridian. The acute angle between the magnetic meridian and the geographical meridian is called the angle of declination at that point. Angle of dip. When a magnetic needle is suspended freely about its center of gravity in such a way that it is free to rotate in a vertical plane, then in a steady state the needle dips down with respect to the horizontal. It has been found that in the northern hemisphere, the north pole of the magnetic needle inclines downward, whereas in the southern hemisphere, the south pole of the needle inclines downward. A magnetic needle which is inclined is called the dip needle. The angle between the axis of the magnetic needle, which lies in the magnetic meridian and the horizontal direction, is called the angle of dip. The magnetic axis of the needle represents the direction of the Earth's magnetic field. Hence, we can define the angle of dip at a place as the angle between the direction of Earth's magnetic field and the horizontal component of the Earth's magnetic field in the magnetic meridian at that place. Displayed here are the positions of the magnetic needle when placed at Earth's magnetic pole and at the magnetic equator. What do you observe? We observe that at the Earth's magnetic poles, the magnetic needle directs in the vertical position and, therefore, the angle of dip is 90 degrees. It means that the magnetic field of the Earth at the Earth's magnetic poles is vertical or perpendicular to the Earth's surface. Similarly, at the magnetic equator, the magnetic needle aligns in a horizontal position and therefore the angle of dip is 0 degrees. It means that the magnetic field of the Earth at the Earth's equator is horizontal or parallel to the Earth's surface. Horizontal component of Earth's magnetic field. We know that except at the equator, the Earth's magnetic field is nowhere horizontal. Therefore, at any place, the Earth's magnetic field in the magnetic meridian may be resolved into two components, namely, the horizontal component BH and the vertical component BV. Shown here is a freely suspended magnetic needle, NS. The vertical plane, OPQR, passing through its axis is the magnetic meridian. The plane OABR is the geographical meridian. The angle between these two planes is the angle of declination. The angle between the axis OQ of the magnetic needle and the horizontal OP is the angle of dip, delta. The axis OQ of the magnetic needle represents the direction of Earth's magnetic field, BE. The field BE can be resolved into horizontal and vertical components, BH and BV. From the figure, we know that horizontal component of Earth's magnetic field, BH, is equal to BE cos delta. Vertical component of Earth's magnetic field, BV, is equal to BE sin delta. Squaring and adding equations, we get BH square plus BV square is equal to BE square cos square delta plus BE square sin square delta. That is equal to BE square. Therefore, BE is equal to root of BH square plus BV square, because sine square delta plus cos square delta is equal to 1. Dividing equations, we get BV by BH is equal to BE sine delta by BE cos delta, that is equal to tan delta. Therefore, delta is equal to tan inverse BV by BH. By knowing the value of theta and delta at a place, we can determine the direction of the magnetic field BE. And if we know the values of B, BH and delta, the magnitude of the Earth's magnetic field BE can be determined. Thus, theta, delta and BH give complete information about the Earth's magnetic field at any particular place. Did you know that aurora, the streamers of light in the sky above the northern pole or southern magnetic pole, are caused by the Earth's magnetic field? When the fast-moving stream of electrons moves down in the Earth's magnetic field, they collide with gas atoms and emit light. The display of colors that is observed in extreme northern latitudes are called aurora borealis, and that observed in extreme southern latitudes are called aurora australis.